Okay, so here's our problem set. Let me get zoomed in here on this first direction, and we'll go from there. It says draw an area model for each pair of fractions and use it to compare it to the two fractions by writing greater than, less than, or equal to on the line. Okay? The first two have been partially done for you. Each rectangle represents one. Okay, so here's this. It shows each rectangle representing one here. And what it's doing is we got 1/2 and I've got 2/3. So what we're trying to do is find a common denominator here, right? So what they did was we realized that you see this 1/2 and this 2/3. In order to really figure out, we need to get the common denominator of 6. They multiplied this 1/2 times 3 to get 6. And they multiplied this 3 here by 2 to get 6. Okay? So what they ended up doing was changing this 1/2 into 3/6, just like that. And then they changed this this 2/3 into 4/6, just like that. And then you can tell, well, 4/6 is more than 3/6. See how that works? So they changed this one into 3/6, and they changed this one into 4/6, like that. Okay. Now, why did they do that? The least common denominator was 6. For example, if I count by 2s, 2, 4, 6, and I count by 3s, 3, 6. 6 is the first, basically the first multiple that we land on. So 6 would be the common multiple between these two, right? So that's why they chose 6. In order to get to 6, they multiplied this by 3 and then this one by 2. All right, we can try the next one here as well. All right, doing 4/5 and comparing it to 3/4. Okay, so when I look at 3/4 and I look at 4/5, I can change these into a common denominator of, say, 20, right? Because 5 times 4 is 20. So both these numbers fit into each other, fit into that 20, all right? So if I take this first one and I say 4/5, and I'm going to multiply that by 4 and this by 4 to end up with 16/20. Okay? And then this 3/4, I'm going to multiply both numerator and denominator by 5. So I can end up with 20ths as my unit. And so you see I have 16/20 and 15/20. Okay? So what does that look like? So I've got, I need to make an array, like an area model out of this. All right? So let's see how I can do that. 16/20. I can make, so this is 1, 2, 3, 4, 5, and I make 4 rows because I multiplied it by 4. So now I got 20 areas, 20 here. See this 4 times 5? And I have 16 of them shaded in. Okay? Then down here, 1, 2, 3, 4, I'm going to make my columns of 5 to make 20 little boxes, the 20ths. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Actually, this one is 16. It's out to here. Get my math off. There. So you can see this is 1/20 bigger than that one. So 4/5 would be bigger. Okay? All right. So I could keep doing this. I could do 5 and 7, go to 35, all right? Make this into 35ths. Over here, 7 and 6, make it into 42nds. That's getting a little crazy for me, all right? What I would rather do is when I get fractions like this, instead of finding the common denominator, I'm just going to use cross multiplication, okay? So I'm going to rewrite this, 3/5 and 4/7. And I'm going to find out which one is bigger by using cross multiplication. 5 times 4 is 20. 7 times 3 is 21. This one's just a tad bit bigger. This is a really good time to use cross multiplication. Okay, when you have fractions here that have common denominators are pretty big. Like if I'm going to make fraction models into 35ths, that's a lot of work. Okay, and then look at this one. It wants me to make fraction models like 7 times 6 into 42. I'm not doing that. So I'm just going to say 3 sevenths and 2 sixths. Now I know both these fractions are less than half, but sixths are bigger than sevenths, right? But there's 3 of these. So this is a really tough one to figure out. Cross multiplication is going to help me with this. 7 times 2 is 14. 6 times 3 is 18. Right? So I know that 3 sevenths is bigger than 2 sixths. All right? Now, if I were to find the common denominator, okay, that's what my numerators would be eventually. If I made this into 40 seconds, it would be 18 40 seconds, and this would be 14 40 seconds. Pretty weird, right? All right, let's check this out. 5/8 and 6/9. It would want me to make area models out in 70 seconds, right? So instead of doing that, I'm going to use the cross multiplication method, okay? So if I were to multiply this one by 9, I'd have to multiply that one by 9, then I'd get this whole different fraction. So if I use cross multiplication, I could figure it out better. 8 times 6 is 48. 9 times 5 is 45, right? So I know that 6/9 is larger, okay? Check out this one, 2/3 and 3/4. Both are greater than half. Both have different numerators and denominators, so cross multiplication is the best method. Okay, 2/3 and 3/4. I could change these both into 12ths. I could do that, okay? Or I could just cross multiply. 3 times 3 is 9. 4 times 2 is 8. Look how close those are. 3/4 or 2/3 is less than 3/4. Okay? All right, let's check out the back. All right, it says rename the fractions as needed using multiplication in order to compare each fractions by writing greater than, less than, or equal to. Okay, so let me show you how cross multiplication works here. 5 and 6. The closest multiple they have in common is 30, because 5 times 6 is 30, right? So if I show you what we're due here, so I say 3/5, and I'd multiply both those by 6, and that would equal 18/30, right? This one, I would take 5/6 and multiply that by 5. And I'd end up with 25/30. See that? So now my denominators are the same, so I'm dealing with the same unit. Now I can just compare the numerators, 18 and 25, and I know that 25 is more. Now, that's how I just changed these two fractions into these two fractions. So instead of doing all that work, if I just did cross multiplication, 5 times 5, isn't that 25? And 6 times 3, isn't that 18? That's where those two numbers come from, okay? So that's why we cross multiply. 6 times 3 is 18. 8 times 2 is 16. 2 6 is less than 3/8. Let's check out this one. Okay. 5 times 10 is 50. 8 times 7 is 56. 7/5 is greater than 10/8. Check out 4/3 and 6/5. Still cross multiplication works. 3 times 6 is 18. 5 times 4 is 20. 4/3 is more. Okay. And then down here it says use any method. Okay. Look at this, is 4th and 8th. Those are related facts. Those would be a little bit easier to take care of. I could just change this to 6/8 by multiplying it by 2 and compare that to 7/8, and I can see that 7/8 is more. Right? Now B is a little different. That's 8 and 5. The closest related fact that I've got between those two is 40. right? So I'm just going to cross multiply. 8 times 3 is 24. 5 times 6 is 30. Guess what? 30 is greater than 24, right? That's right. Okay, it's at 30, it'd be 40 there, okay? All right, then down here, this is dealing with fourths and sixths. The closest related fact I have between those is actually twelfths, okay? But 24 is also a related fact. So if I do 4 times 8, 32, 6 times 6, 36. 6 fourths is greater than 8 sixths. And then the last one, fifth and sixths. The closest related factor I've got between those two, or multiple between those two, is 30. So 5 times 9 is 45. 6 times 8 is 48. 8 fifths is greater. Okay? All right, kids. I think there's one more problem on the back. We're not going to do that. All right? We're going to be done with this for today. All right? And we're actually going, you guys can take these packets home. And if you haven't been taking the individual papers home, that's fine. And then we're going to start our next fraction packet, all right, which we'll get on actually Monday. Tomorrow, we'll be doing a math mystery, all right? I know you're going to love it. All right, kids, nice job today, and we'll see you tomorrow.